So let's start now our today's lecture, inductor and inductance. So what is an inductor? An inductor is a passive component that is used in most power electronic circuits to store energy in the form of magnetic energy when electricity is applied to it. One of the key properties of an inductor is that it impedes or opposes any change in the amount of current flowing through it. Whenever the current across inductor changes, it either acquires charge or loses charge in order to equalize the current passing through it. The inductor is also called a choke, reactor, or just a coil. So basically, an inductor is used to balance the current because it stores the energy in the form of magnetic energy. Whenever electric current is flowing through it, electric field or magnetic field is created and it stores energy in the form of magnetic energy. So these are some type of inductors: air air core, iron core, or ferrite core. In air core, these are the symbols and these are the real shapes. So mostly you see in your electrical or electronic components such type of inductors, and now we will study about that, what are their applications and where they are used. So first I will tell you what is. Now we know inductor is an passive device which can store energy in the form of magnetic energy whenever the current is flowing. So what is inductance? Inductance is the ability of an inductor to store energy, and it does this in the magnetic field that is created by the flow of electric current. Inductance is caused by magnetic field generated by the electric current flow through an electrical circuit. Typically, coils of wire are used as a coil increases the coupling of the magnetic field and increases the effect. So an inductor is a passive component which stores energy in the form of magnetic energy. So its ability to store energy, that how much energy it can store, how much magnetic field it can create, this ability of an inductor is called its inductance. So why mostly coil is used or wires are used? Because they, whenever a current will flow through a wire or a coil, it will create a magnetic field around it, and that is the work of the inductor, to store energy in the form of magnetic field, and the ability of storing that energy is called inductance. So we will talk first about the iron core inductor, that is this one. The second one, that is in round shape and a wire is coiled around it with the two legs. As the name suggested, the core of this type of inductor is made of iron. These conductors are low space inductors that are high power and high inductance value. However, they are limited in high frequency capacity. These inductors are used in audio equipments. So, as we know, the working of a conductor means it is a passive component that can store energy in the form of magnetic energy when current flows through it, and its ability is called inductance. So iron core inductors are the inductors which have high capacity, that can store high power or high magnetic field. So whenever there is a high power, high frequency, this means it's working on a high frequency, and they are mostly used in audio equipments. Air core inductor, this is the first one. The difference between these two are they are in a circular form. They are like in a cylindrical shape, but no cylinder is in between this. Only the space is the medium of this inductor. So where we use this type of inductor, these inductors are used when the amount of inductance required is low. As we studied that in iron core inductor, mostly they are used in high frequency or in audio equipments, but where we want to use the low power or low energy equipments, there we use the air core inductor, because the amount of inductance required is low since there is no core. That's why there is a air in between the wires. You can see there is no core in that. Here the coal is a, there is a wire inside that where the wire is wrapped around, or there is an iron. See, this is the iron rod or iron something where wire is. Here we have a another ferrite coil and the wire, but here the wire, the inside of the wire is empty. There is no iron or ferrite inside there. So since there is no core, it does not have a, it does not have a core loss, because whenever there is a medium inside there, even iron or a ferrite, there will be some loss. But as there is no core, so there will be no loss of energy. But the number of turns the indicator must have is more for this type when compared with the inductors with the core. This results in a high quality factor. Usually ceramic inductor are often referred to as a air core inductors. So this type of inductors are mostly used when we need a less waste of energy, or you can say we can have when we want that our inductor or equipment required a low inductance, because there are no core inside that, so the loss will be very little. Ferrite core inductors. In this type of inductor, ferrite material are used, as I told before. Instead of iron, ferrite is used. So two types of, there will be soft or hard. Soft ferrite, materials that have ability to reverse their polarity without any external energy. No external power is given that materials. And in hard, they are permanent magnets. That is, their polarity will not change even when the magnetic field is removed. So some are where external energy, without an external energy they are used, and some those which are permanent already magnet. So what are the functions of the inductor? Inductors have basically two primary functions: to control the signals and to store the energy. So what is to control the signal? I think this control, yes, control these functions of the inductors and the numericals we will do in our third part of the lecture.